These days, a lot of people on boats rely on AIS to assist with their collision avoidance. I've heard stories from sailors who came across commercial or fishing vessels which had their AIS transmission turned off. As an additional level of safety, I was wondering whether it is possible to make a marine radar detector with off-the-shelf components. Welcome to my channel. My name is Alfred, and in this video I wanted to demonstrate how I built a marine radar detector prototype. Marine radar generally operates in the X-band somewhere around 9 GHz. In addition, larger vessels also use radar in the S-band, which performs better in foggy weather and heavy rain. The output power of marine radar systems is between 2 kilowatts and 30 kilowatts, or 63 dBm to 75 dBm. The radar pulse width is around 50 nanoseconds. I have created a simple block diagram that shows the design of the marine radar detector prototype. On the left-hand side, you see an ultra-wide broadband antenna that can support frequencies between 3.9 and 10.5 gigahertz. The incoming signal is then filtered through a 9 gigahertz filter. The low noise amplifier was introduced in the design at a later stage when I noticed that the received signal was too small to be detected by the power detector. The power detector converts the received power into the related voltage. Depending on the voltage level from the power detector, the Schmitt trigger creates a 1 or a 0 at the output. The trigger level can be set from -10 dBm to -60 dBm. The function of the one-shot is then to convert a very short radar pulse into a longer pulse that can be displayed on an LED. And this is the circuit schematic following from left to right. You see the ultra-wide broadband antenna, followed by the mini circuit high-pass filter, and then the Synco LNA, the low noise amplifier, that has a built-in battery, rechargeable battery, which can be quite useful. That low noise amplifier provides a gain of about 13 decibel at 9 gigahertz. The next component is the power detector module AD6317 that can work up to 10 gigahertz. Following the power detector module is the Schmitt trigger that is based on the AD8041 op-amp. The AD8041 is a fast op-amp that was required because of the short pulse length of the radar signal. The one-shot is based on the 555 timer integrated circuit. This circuit component has been around since I was a teenager, and the component is very versatile. I have used the ICM 7555, the CMOS version, because of the short input pulse. And this is a picture of the prototype. I've mounted the components onto a piece of perspex that should have little impact on the high radar frequency. On the left-hand side is the ultra-wide broadband antenna followed by the filter, the low noise amplifier, and the power detector module. On the right-hand side is a breadboard with some of the components for the Smith trigger and the one-shot. I've powered the electronics with a power pack, 5-volt power pack, that was quite handy to have out in the field. For the testing of the marine radar detector, I went to Sydney Harbour. I conducted 2 separate tests. The first test was without the LNA. I set the sensitivity of the Schmidt trigger to approximately minus 40 dBm. The distance between myself and the tankers docked at the unloading dock was approximately 100 meters. I could clearly detect the radar signal from the 2 tankers. The second test was with the low noise amplifier. I went to a different location, overseeing Sydney Harbour, the Harbour Bridge, and the city. Initially, I set the sensitivity to about minus 40 dBm, and I could detect a number of targets. Most of them were not visible to the eye. Then I changed sensitivity to minus 25 dBm, and I could associate the targets with the detection. An example was a fisheries boat that was approximately half a sea mile away that I could detect going past. In summary, the marine radar detector prototype worked quite well to detect vessels about half a sea mile to a sea mile away. However, to have the equipment operating on a boat, for example, some improvements are required. One of those improvements would be to create the proper PCB for the electronics and house the equipment in a Perspex case. I would use Perspex to have little impact on the radar frequency. Another side is the output. The prototype only has a LED to signal whether there is a vessel that is sending a radar signal nearby. However, it would be very useful to have a sounder instead of the LED with a reset function similar to an AIS. The other area is the frequency band. The current prototype operates in the X band. However, it would be useful to have a detector for S band as well. To accommodate S band, the most likely scenario and the most cost-effective scenario would to create a second piece of equipment. The main difference between the X band and the S band marine radar detector would be the filter that would need to be changed from 9 gigahertz to approximately 3 gigahertz. Thank you for watching my video. Please provide comments, and if you like the video, like and subscribe. Thank you very much. Bye.